بسم الله الرحمن الرحيم. السلام عليكم. How are you شباب? Today inshallah شباب we will talk here our next part, second part of instrumentation measurement 2 for the course code EE221 in the semester 422, the coronavirus semester, second semester inshallah. طيب, this part here will give you introduction for some physical properties, and it is important to review them and also to test your knowledge about this terminology. It's very important. It can helpful in our measurement and also to help us to understand them. طيب, before going to the coming subject, which is density, viscosity, humidity, and also pH measurement, we need to know the meaning for the original or can say the basics units. Just let's go through them and to understand them more clearly and very details. Bismillah ar-Rahman. Let's start. Our first terminologies. Length. We know all of us that the meaning of length, we can describe it as the shortest distance between 2 points. It is occupancy of one dimension space. Like example, 1 meter. If we say 1 meter, it's mean a length, unit of length. Area is occupancy of 2 dimensions in the space. The first one, which is the length, it's scale, 1 dimension. The other, which is the area, is 2-dimension occupancy in the space. As example, if we say 2 meters square, that's mean area, units, length and width. So you can here talk about here some flat surface or volume. It is occupancy of 3-dimension in space, like a cup of water, like what we are here now in our existence life. We are living in 3-dimension. As example, if I say 2 meter cubic, that's mean a volume unit is 2 meter to the power 3. The width, calculation in width and length and height, or you can say azimuth, longitude and altitude in other descriptions. Right. Now we go to the distance definitions. Distance, simply, it is how far between 2 points or 2 locations. Simple. It is a scalar amount, but if we add a direction to this magnitude or this value, it will give us a new terminology. We call it displacement. As example, if we say 1 meter distance, but without mention the direction, just we'll talk here about distance. But if I mention it as 1 meter and I give also the direction 1 meter to the right, mean a displacement has done with a magnitude equal to 1 meters and the direction to the right side. I can express this displacement mathematically as absolute value and 1 meter, which is the magnitude value here, multiplied by the cosine 0. Of course, we know that if I make a cosine 0, that means 1, and sine 0, it means 0. So if we apply it in the Cartesian coordinations, if you go to the x-axis, it will give you only direction to the x-axis and the right side, to the positive number. There is no direction to the y side or to the z side, if you want to mention it. Type the speed, it is the rate of distance changed by the time. How much distance is happened or is applied per unit of time. If we add a direction to it, it becomes as velocity. So velocity is the speed with direction. Example, if I say 1 meter per second, that means speed, but if I add a direction to it, it means 1 meter per second, and I give the direction right. That's mean I can say 1 meter second in the right side, or can say in the positive number of x-axis. If you say that in Cartesian coordination. Cartesian يعني شباب معناته هو ايش؟ الإحداثيات السينية والصادية والعينية. x y z. azimuth, longitude, altitude. طيب we can express it as 1 meter per second. All of them is magnitude as absolute value, multiply the cosine 0, because I mentioned what? Right. That's mean in the positive side of the x-axis, and we know that cosine 0 is 1 and the sine 0 is 0. That's mean only one direction in x-axis. طيب acceleration, it is the rate of speed or velocity changed by the time. Distance changed by the time is speed. Then again the same speed, if it is changed by the time, it's give me an acceleration. So the time here is calculated 2 times in the denominator, see here, square. So it is a scalar acceleration. If I say that 1 meter per second square, if I say 1 meter per second square in the left side, that means a vector acceleration, and we can express it as 1 meter per second square, all of them absolute value, which is the magnitude, multiply the cosine 180 degrees. Notice here I mentioned 100 degrees. That's mean in the x-axis, but in the toward the negative values, negative numbers. So in the negative side of the x-axis, and also only happened in the along the x-axis itself, the original axis. There is no y coordination, there is no z coordination here. Now we mentioned this acceleration, distance, velocity. Now we'll go to the mass, which is expressed as the amount of matter in object. Amount of matter in object. It is related to molecules of the matter يا شباب. It is scalar amount. Scalar. Cannot be becomes a vector. So if I say object has a mass equal 1 kilogram, which means the amount of matter of this object is 1 kilogram. نحن نتكلم عن كمية يا شباب، كمية المادة. كم أي مادة عندنا في الحياة، أي شيء، أي كائن في الحياة، كم المادة الموجودة جوته، كم عددها، كم كميتها. هذه هي يا شباب الماس، كيلوغرام. Because here mass, if you mention mass, many people they confuse between the mass and the weight. الوزن، كتلة والوزن. In order to distinguish between them, let's us talk about the force first. As per the Newton's second law of motion, force is a product of mass and acceleration. ضرب التسارع والكتلة، هذا القوة. It is a vector amount, but we can take the magnitude only sometimes. Object has force 50 Newton, and we don't mention the direction, just we take the magnitude value only. That means its acceleration, it has acts as acceleration multiply in its mass, and the result is becomes 50 Newton, and this is the unit of the force. Now let's go to the weight. It is a special case of the force, which is the force exerted by the earth acceleration gravity. So it is related to the gravity of the earth, which means the direction always be downside. If an object has weight equal 1 Newton, weight, I didn't mention as a force, I mentioned it as weight, that means immediately the acceleration is the gravity, which is 9.81 meter per second square. That means almost equal 0.102 kilogram exerted by the gravity acceleration, multiplied by these values, it gives me 1 Newton. I can express it in other mathematical, I can express it in mathematical way as 0.102 kilogram multiplied by 9.81 meter per second square, all of them absolute value as a magnitude, multiplied by the cosine 20 270 degree. So this multiplication to give me 1 Newton. Multiply cosine 270 degree. Of course, if I apply it, it becomes -1. So the direction here is in y-axis, but in the negative sides. The negative side of y-axis. There is no x-axis here. X-axis is almost 0 here, as the original. And there is no z-axis here. Only just to the ground immediately. Right. Now let's start يا شباب talk about the fluids. Fluids are substances, but they are deformed under any shear stress regarding how much this stress is small, and they will take the shape of their container. So I can say موائع. fluids يعني موائع يا شباب. مادة مائعة تتحرك بشكل متغير، قابلة للتغيير، قابلة للتشكل، تأخذ شكل الوعاء الذي توضع فيه. أي عملية ضغط أو عملية كبس بسيطة أو شيء على طول يأثر على السطح ويأثر على البروفايل. So the profile shape شكل الحركة أو النمط الذي تمشي فيه الفلوت يختلف بناء على اختلاف الضغط والكبس أو الشد أو الجهد المبذول عليها. طيب there are properties, they call it specific properties، الخصائص الخاصة بالمادة. So these specific properties are related to the element types of the substance. يعتمد على نوعية العناصر الموجودة في المادة. In general there are basic properties for substances like regarding the status. حتى المواد الصلبة نفس الشيء، يعني ليست فقط للفلويد يعني شباب، ليست الموائع. Even for the solid, not only just for liquid and gases or fluids, it is also included fluids with the solids. We know these properties. I think most of us we know these. Just go quickly for them. Density, and we can say a specific mass. This is another name for density على فكرة يا شباب. Density or specific mass. Sometimes it's called mass density. Specific volume and specific weight. Sometimes it's called weight density and specific gravity. Now I will show you يا شباب a video. I take it from the YouTube. I think it is helpful for us to understand the meaning of these four contents. It gives you the definitions and also the equation in summarized way. I think it's good, and listen to it now شباب.
Welcome. In this video, let us see the properties of fluids: density, specific weight, specific volume, and specific gravity. So let us see the first one, density. Density is actually the mass by volume. So it is also known as mass density and specific mass. And in general sense, it is a measure of mass of fluid occupying 1 cubic meter of space. I will show you one cube here, which is having 1 meter length, 1 meter width, and 1 meter height. It is a cubic meter. So we are measuring how much mass of the fluid can be laid in it. So this is mass of the fluid in it by its volume. Technically, it is defined as mass of the fluid per unit volume, and it is denoted by the Greek letter rho. And mathematically, we can write it as rho is equal to mass of fluid by volume of fluid, m by v. And the units are kg per meter cube. And if you see the diagram here, so I have given you two cubes here. One cube is having the substance which is having loosely packed molecules. It is another substance which is having closely packed molecules. So you can say very well it is very denser than this. And the most important thing you have to remember is the density of water, which is 1000 kg per meter cube or 1 gram per cc. Please remember that the value is very important. And let us see the applications of density. Where can we see this? Oil floats on water because it is of less dense than water. And take some bowl of water and pour some oil in it. Oil will definitely float, right? Because the oil is less dense than water. And if you see this fluid tower, this is the tower of fluids having different densities. So last one is honey because it is a more denser. On that corn syrup, which is lesser denser than honey, and all the fluids are in descending order of their densities. Honey, if you compare, it is having lot of density compared to the ping pong ball, which is having lesser density. And boating is possible because it floats on the water. This is because boat is less denser than water. And now your work is to find out some more examples. And density of some more important materials I am giving to you: water 1000 kg per meter cube, cement 1440 kg per meter cube. So here I am giving you the important building materials densities, and dry sand, steel, brick, mercury. And now your duty is to search some density of some more materials. So second property is specific weight, so which is denoted by small w, and it is also known as weight density, and is a measure of weight of substance which occupies 1 cubic meter of space. So technically it is a weight by volume, so it is denoted by small w, that is equal to weight by fluid by volume of fluid. And weight we can call it as mass into acceleration due to gravity. W is equal to mg. So we can now write it as small w is capital W by V is equal to mg by V. M by V, that is the density previously we have discussed, so we can substitute it here, rho g, and the units are Newton per meter cube. And what are the uses of specific weight in fluid mechanics? So fluid mechanics, specific weight represents the force exerted by the gravity on a unit volume of fluid. So mass is a constant, it will not change anywhere, but weight will change according to the planet. Our Earth planet is having some gravity, and its acceleration is 9.81 meter per second. So we are measuring the mass by virtue of gravity. Mass, which is in the influence of gravity, that is actually weight, and we call it as even force. So that is why we are representing it as Newton per meter cube. So let us see the third one, a specific volume. It is reversed to the density. So it is volume by mass. To say mathematically, that is volume by mass. It is actually the property of material which is defined as number of cubic meters occupied by 1 kilogram of particular substance. 1 kg is occupying how much volume? That is a measure. So volume of fluid by mass of the fluid, V by M. This is the reciprocal of density, that is 1 by rho. And the units are meter cube per kg, reverse to density. So fourth one, last one, specific gravity. And specific gravity, it is denoted by capital S, and it is the ratio of density of that substance to the density of reference substance. So mathematically we can write it as density of fluid by density of reference fluid, rho fluid by rho reference fluid. And reference fluid is here for liquids water and gases air. And we know that very well, liquids and gases both together are called as fluids. It is a dimensionless quantity because it is the ratio of two fluids, right? So it is the ratio of densities of fluids. So rho fluid by rho reference liquid. So if we talk about density of liquids, specific gravity of liquids, that is the ratio of density of liquids to the density of water, rho liquid by rho water. Density of water is 1000 kg per meter cube. I repeat it again, please remember. Specific gravity of water is 1, because when we talk about specific gravity of water, we have to put that density of liquid is density of water by reference liquid is also water. So density of water by density of water, that is 1, and the units will be cancelled out. The unit, this is the dimensionless quantity, and here it is the density. Please check the spelling. And what are the applications of specific gravity? And it is just a measure that shows us how much a liquid is denser or more denser or less denser than water. For example, if specific gravity is more than 1, so we can say that is more denser than water. And for example, any liquid is having specific gravity less than 1, we can say it is lesser denser than water, and it floats on water. For example, you can think of a plastic ball floating on the water. See here, it's a ball floating on the water because ball is having less specific gravity or less denser than water, so it is flowing on it. So you can think of an iron ball in the same place. What will happen? It will sink, right? Because iron ball is more denser than water. So specific gravity of some important materials here: water is 1, mercury is 13.6, steel, cast iron, aluminium, gold I have given to you, And now your duty is to collect some more specific gravity values of some more materials. And let us see a problem now. So question is to calculate the density, specific weight and weight of 1 liter of petrol of specific gravity 0.7. So what they have given us, initially they said 1 liter of petrol. So they have given volume 1 liter, that is 1000 centimeter cube. We can convert into meter cube. So because 1 centimeter is 1 by 100 meter, so that is whole cube, we will get it as 1 by 1000 meter cube. Specific gravity they have given us as 0.7. So actually specific gravity volume is rho liquid by rho water, and rho water is, whether they have given or not, that is 1000 kg per meter cube. Rho petrol, so if we substitute that, rho petrol by 100, that is equal to 0.7 specific gravity. So rho petrol we can get it as 0.7 into 700, 1000, that is 700 kg per meter cube. So density of petrol we got it as 700 kg per meter cube. So first one we got it. So second one we have to find out specific weight. After that we have to find out the weight. See that specific weight, small w we need to find out. First write the formula, that is small w is weight by volume, but we don't have weight. So let us check. W is also known as mg, so m by v is also known as rho g. So initially we have found out the density here, the 700 kg per meter cube. Let us substitute it here. So W is equal to rho petrol into G, 700 into 9.81, that is 6867 Newton per meter cube. And the weight we need to find out. Again write the formula for weight density, which is small w is equal to weight of fluid by volume of fluid. And W is equal to, we can write as, if we want weight, weight is equal to volume into weight, weight density. See, weight density we have just calculated it, just substitute, very easy. So you will get 6.867 Newton. Volume is 1 by 1000 meter cube.
Fluids used in mechanical systems come in many different types. The type of fluid chosen for a particular application depends on its characteristics. One of the most important characteristics of a fluid is its viscosity. Viscosity is defined as a fluid's resistance to flow. Fluids with low viscosity flow very easily. Water is a type of fluid with low viscosity. Fluids with high viscosity are more resistant to flow. Honey is a type of fluid with a high viscosity. Therefore, honey is more viscous than water. Another characteristic of fluids is the viscosity index. This rating relates the flow of a fluid with its temperature. Many fluids begin to flow more easily as temperature increases. The viscosity index is the measurement of this characteristic. A high viscosity index indicates a small oil viscosity change with temperature. A low viscosity index indicates a large oil viscosity change with temperature. Compressibility is another characteristic of fluids. It measures the change in volume of a fluid as a response to a change in pressure. Fluids, such as gases, are highly compressible. Their volumes change significantly when placed under pressure. Liquid fluids also have a compressibility factor. Water and petroleum-based hydraulic fluid are almost completely incompressible. They don't compress when put under pressure. This characteristic is what allows them to be used to transmit power in fluid systems. Years ago, water was used as the first hydraulic fluid because there was no other liquid available in such large quantities at such a low cost. There are some major drawbacks to using water as a working fluid. Due to its low viscosity, it is difficult to pump. Additionally, the speed at which it flows through the system causes an effect known as wire drawing. Wire drawing occurs when the water flow erodes or scores a pathway in the metal of machinery as it goes around corners and through orifices. It also has corrosive effects on metal machinery. Over time, petroleum-based hydraulic fluids have become much more cost-effective. For starters, it has a lower specific gravity than any other liquid and can be pumped with less power loss. It also lubricates as it works through the system and has little corrosive effects on metal machinery. Flammability is an issue, but with the development of synthetic oils, alternatives to water remain the preferred working fluid. Several factors should be considered when designing a fluid system that uses a petroleum-based hydraulic fluid. The first is cleanliness. Oil never wears out, but it can become so contaminated that it is unfit for further use. Fluid systems frequently employ filters throughout the system to help reduce contaminants. They may also require complete fluid replacement after certain time intervals, and this can become cost prohibitive with larger systems. Another factor common to hydraulic fluids are the use of additives. Additives can be used to reduce aeration and the production of bubbles as the fluid travels rapidly throughout the system. They can be used to administer corrosion inhibitors within the reservoir, and they can be used as a demulsifying agent, which helps the fluid resist mixing with water. The choice of modern fluids is so wide that when designing a new system, fluid characteristics such as viscosity, viscosity index, cleanliness, filtration, and additives should be considered as early as possible in the design process.
For this lecture, our objectives here to review the concept of density, and we'll see the formula used for measuring the density. How are they formula? How can we utilize them, and how can derive these formula? Technique used for measuring the density, and some example for them. Okay, let's just go to the idea for density. What's the density? Here we talk already that density is the mass rate over the volume, or you can say how much mass per unit of volume. But maybe our student here, they confuse sometimes between the concepts. So here just we want to emphasize the meaning of the density. First, if we talk about mass, that you are talking about the content material, the contents, how many molecules inside the material, inside the matters. If you have a matter, any matter in the life, and it contains some molecules, substance, how many molecules are there? So how many a molecule will occupy this space? Occupation the space is the volume, and if you talk about the amount of molecules, you talk about mass. Okay, what about the how much are compact together, these molecules? How can they are compact in the defined volume size? Just let's see this video together, just for taking more deep understanding for the density.
What is density? Density is how tightly packed mass is in a certain amount of space. So if we have more mass packed into an amount of space, we consider it more dense than if we have less mass packed into that same amount of space. We measure density in units called kilograms per meter cubed. Kilograms are a measure of mass, and meters cubed is a measure of volume. So to measure density, you're measuring how much mass is packed in to a certain amount of space. How many kilograms are packed into 1 cubic meter. So let's look at some examples. If each sphere is equal to 1 kilogram, this cubic meter contains 1, 2, 3, 4 kilograms of mass. So that would be 4 kilograms per meter cubed. And that's a measure of its density. Another example would be 1, 2, 3, 4, 5, 6, 7 kilograms in 1 cubic meter. So it would be 7 kilograms per meter cubed.
Okay, we need to understand this density now. We already explained the idea of density. Here we talk about the compact tightly together. Now, just we won't just go to the other variables that related to the density: mass, volume, weight, pressure, and temperature, especially for gases. When I say especially for gases, does not mean that I will discard or I will delete the liquids. No. Also include the liquids and solids in the same time. But gases are the more affected strongly by the change in the temperature, more than the liquid and solids. Okay, let's go to some formulas. Common formulas for the density, which is the famous one. We say that density, and we use the simple rho, which is equal mass over volume. And the unit here in SI system, you call it kg over meter cube. Mass kg and the volume is meter cube. This is the formula for density. And if we multiply the density rho by J, which is the acceleration of gravity here, it can be rewritten again to give us this gamma. What is this gamma? It is the weight of the material over volume. And we remember that weight is a part, or it is a special type of forces which has acceleration related to the gravity of Earth. And this will give us the specific weight, and we use the symbol indicated as gamma. Specific weight is Newton per meter cube in SI system, and we know the weight is Newton, the volume is meter cube. Okay, so we have here density as m over v and specific weight as weight over volume. See the difference? Here is weight and here is a mass. Okay, for the density, by utilizing the hydrostatic pressure, we know the hydrostatic pressure, it is a pressure for the high effect or the height of the liquid inside the containers. Okay, if we multiply the height with the specific weight, we will go into the result. You can see here, as is derived in front of you, the L, which is specific weight. We can see specific weight is weight over volume, and we know that volume, you can say, is the height multiplied the area. This height will go with this height, and it give me weight over area, and we know this weight, it is a force, so I can say force over area, which is equal what? Pressure. In SI systems, Newton over meter square, it is kilopascal. Newton per meter square, it is equal what? Pascal. This is the famous Newton, the famous unit in SI system. So we have here three formula: one for the density, one for the specific weight, which is derived from the density formula, and also one for the hydrostatic pressure. Three formulas, famous formulas for measuring the density. So as mentioned here, we can rewrite this formula, which is pressure, as height multiply gravity multiply density. Okay, based on this formula, we can say any change in density can be affected by the following factor: either to change the volume if the mass and weight is constant, or changing the mass or weight if the volume is constant, or changing the pressure at constant temperature, especially for gases. And also we can say also changing the mass and volume at the same times. Also all of them affect. So we can write the formula that describe each one. Changing in the volume, that means the volume will be changed. That means my density will be changed if my mass is still constant. And also, if I change my mass with the constant volume, of course, it will change my density. So, the same thing also, that in changing the hydrostatic pressure while keeping the same height and the same gravity, that means my density is changed. Here, if I say here mass constant and the volume is changed, here I can say most of the application for this formula, it can be useful for gases. Can be useful for gases. Of course, we will not exclude the liquids and solids, but here I just here mention it is concentrated. The utilizing of this formula concentrate for gases most of the time, but does not mean we'll discard or ignore the liquid and solid. No, we will not ignore them. But normally is used for gases, and it can be applicable. It can be applicable for the liquid and solids. Other formula, which is say changing the mass and fixing the volume. Here you have here a fixed volume, and we will see some application for this one. Of course, if the mass is changed and the volume does not change, that means my density is changed. If you increase the mass and the same volume, you don't change. There is no effect in the volume size. That means my density is increased. Also, the same thing for hydrostatic pressure. Increasing the pressure and fixing the length or the height with the gravity, that means the density is increased. All these factors affect and the density change. طيب. Now let's go to the buoyancy. Buoyancy force, which is a force generated from the fluid, which will push the object upside or opposite the gravity for any object that immerses inside it. So we have here three status of objects which are immersed in the fluids, in a fluid. These three status either to be floated objects above the surface of the liquid, or totally submerged. I mean, it sinks totally, all the volume are covered, or the volume of this object is covered, but it hangs up inside the material, inside the liquid, and some space in the media inside the liquid. And here the third case, it is totally sank in the bottom of the fluid. Okay, what will be the effects of these three cases? Density of objects is less than the liquid. Which case? The floated object. If the object is floated, that means the density of this object is lower than the liquid. In this situation, the weight of bouncy forces will equal the weight of the object. And we can say also this bouncy force, I can say another expression, the weight of the displaced liquid. Apparent weight after immersing the object in the liquid will be 0, because we say here bouncy force equal the object, so there is no difference between them. So there is no difference between them, which is here apparent weight. Maybe so no weight will be comes to me in front of me. طيب, the volume. The volume for objects will be lower than the volume for the displaced liquid, because it is not totally immersed, simply based on the Archimedes principle. Now, for these floated objects, we say that density for the objects lower than the liquid, the bouncy force equal the object weight, and the volume of objects will be greater than the displaced liquid. Second case, if the object is totally immersed in the liquid but not in the bottom of the liquid, so it hangs in the middle, in the medium space of the liquid or volume of the liquid, it hangs in the middle of the liquid. So the density of this in this case of the density, object density, will be greater than the liquid. That's why liquid cannot resist or cannot push it above to the surface. And of course the weight of object will be greater than the bounty force. Or you can say the weight of the object is greater than displaced liquid. Now in this case I have apparent weight. There is a difference here, because there is a difference between the bounty force and the object, mean I have apparent weight. There is a difference in the weight between them. So this formula is coming up. Apparent weight equal the difference between the object of weight minus the force bounty. Displaced volume in this situation will be equal. By the way, the displaced liquid, it has the maximum volume which is equal the object. So it's reached the maximum volume, which is the object volume. It will not exceed the object volume, by the way, based on the Archimedes principle, of course. Now this is the second case. The object is totally immersed in the liquid, but not saying totally and in the bottoms of the liquid. The density of the object greater than liquid, the bounty force lower than the object, and there is a value for apparent weight, and the volume for the object equal the volume for displaced liquid in this situation. Now go to the bouncy force for the object sank in the bottom, or bounty force, and the object sank in the bottom of the liquid. In this situation the density of object is greater than the liquid, similar to the previous one, but the bounty force is 0, or the displaced weight of the liquid is equal 0. The apparent weight in this situation equal the weight of the object, will equal the weight of the object, because because the bounty force is almost 0. There is no change, there is no effect for the bounce in this situation. You can say it is a special case of the merged. You can say it is a special case of this one. So it is becomes like that one is very small comparing to the weight of object. That's leading me to say, okay, it is almost 0. So we neglect the value for this force in this situation. That give me apparent weight equal the weight of object. Also the volume the same idea. It reached the maximum. What is the maximum volume for the displaced liquid? It is the weight of the volume of the object. So density of the object greater than the liquid. Bounty force is almost 0. The apparent weight it's almost equal to the weight of object, and the volume it reached the maximum, which is equal the object volume, not more than that. Now let's go to the technique for measuring the density. As per this previous formula, we can utilize them to measure the density. Okay, one of the famous methods, and the simplest one, is utilizing the displacement method. What is the displacement method? I know a mass or device which has a known mass and known weight, and I will immerse it inside the liquid. Then test the effects of this liquid and test its bounty force. How much? For this technique I will pass it. I will not go in detail for this technique, because it will be the question number 1 in quiz number 1. So it will be part of the quiz number 1. The answer for this technique will be part of the quiz number 1. As see here, research for a device with a famous name used for measuring the density. Its principle of work based on the Archimedes principle. What is the name of the device? Tell me the name, ya shabab, and explain its work. What's the principle, how it's work, how it's running, and is there any upgrading, or is there any types, special types or different type for the same devices? research in this device in the net, or maybe in your reference, your box for the instrumentation, and tell me what is the name of this device that depend on the displacement method or Archimedes principle. In other way, depend on the buoyancy principle or buoyancy force. What is the name of this device? Explain it and give me the types and explain the types if there is a types, and I sure there is a types. From now I will tell you there are types for this device. Just explain what's the difference between these types. By the way, it is part of quiz number 1. You will need to submit it for me, inshallah azawajal, in the coming weeks. I will give you, inshallah, location for submitting this answer for this quiz. Now let's go to the other technique. But before that, we need to find some calculations just to take more understanding for the buoyancy idea. If I have a boat, of course I want to know what's the density of this boat. If I put this boat in the seawater, the density of seawater at 27 degree has 1023 kilogram per meter cube. Now if the boat has a mass 3500 kilogram, it is a small one, it is immersed third of its volume, not all, let's say third of its volume is immersed. What will be the density? Okay, weight of the boat, it is the object weight. I have the density, so I can just multiply the acceleration of gravity by the mass of this boat and give me the weight of it, which is 34,335 Newton. The boat is floating. That means the buoyancy force will equal the weight of the boat because it's floating there. So buoyancy force, it is the same as the object because it's floating. So buoyancy force in this case is 34,335 newtons. Now, and I can find the volume of the boat. I know the specific gravity or specific weight for the water. Just multiply the acceleration of gravity, multiply the density. You already know the density of water, multiply it with the acceleration of gravity, and we will find the displaced volume. And we know already the buoyancy force. So the displaced volume, after calculations, it gives me 3.421 meter cube. So it is giving me that the volume of boat equal 3 times volume of displaced, because he mentioned what? If the boat has 30,000 mass and it's mere third of its volume, that means the displaced volume equal the 1 out of 3 of the total volume, and this total volume is the boat volume. It will be not more than the boat volume. So the volume of boat is 3 times the volume displaced in this situation, because it is the first case, which is floating object. Now I can multiply these 3 by the volume of displaced, which is already found it. It gives me the value for the boat volumes. So we can say the density of the boat, just divide the mass of the boat over what? Over its volume. 3,500 kilogram per 10.264 meter. It gives me the resultant one. So the density of boats is 341 kilogram per meter cube. طيب, another types of measurement devices that measure the density is the pycnometer. Pycnometer is a device that measures the density by fixing the volume. It is a glass flask with a close fitting ground glass stopper with a caliper hole through it. This fine hole releases a spare liquid after closing a top filled picometer, and allows for obtaining a given volume of measured and working liquid with high accuracy. Normally they compare it with the water.
These clever little gadgets. It's called a pycnometer, and here's how it works. A pycnometer consists of two pieces, a small flask and a glass stopper with a built-in capillary tube. When you fill the flask to the bottom of the neck and then insert the stopper, the liquid is forced up to the tip of the capillary. Dab away any excess, and the liquid is guaranteed to occupy a volume that is very precisely prescribed. Once you've determined what that volume is, it's trivial to measure the density of any liquid simply by measuring its weight.
Now, usually they're using this pycnometer to compare material density with the distillated water, as you saw in the videos. Okay, now if we say that the same volume, that means the volume of the liquid equal the volume of water, so I can say volume of liquid equal the volume of water, or I can substitute for the volume based on the density formula, which is mass of the liquid over the density of the liquid, which is equal mass of water over the density of water. I know the density of water already is known to us, which is the distillated water density at defined temperature, either 25 to 20, 0%, 0 degrees Celsius, whatever, depending on the degree or the ambient temperature around the pycnometer during these times, which is multiplied by the mass of the liquid over the mass of water. Just I need to find the mass of the liquid using the normal balance and divided by the mass of the water, also using the same balance. Just multiply them and it will give me the density of this liquid. So pycnometer, it's apply the rules that changing the mass with fixing the volume. Here is example. A density of distillated water is 997.05 kilogram per meter cube at 20 degrees Celsius. Use in pycnometer to find the type of material, which give a weight 12.64 Newton. What is this material? So he told me distillated water is used in pycnometer, and he told me that the weight for this material is 12.64 Newton. And also to give me material mass for the water. I forgot to mention it there. It's mentioned here يا شباب. It's mentioned here. See here يا شباب, the mass of water itself, which is in reality they give me a weight 11.775 Newton as a weight. Okay, now this is the formula. Density of liquid equal the density of water multiply the mass of liquid over the mass of water. We know to find the mass of liquid, just divide the given weight by the acceleration of gravity. The same thing for the water. Just take it and divide its weight with the acceleration of gravity. Divide both of them and multiply them in the density of water. It gives me the final results. So my material is 1449 kilogram per meter cube. If you search in the web, and you will find the tables there for some common fluids, and if you see this value, you will discover it is what? Acetic acid. So my material is what? Acetic acid. Okay, this is a method for using pycnometer for measuring the density. The accuracy for this type is really, it's a little bit very high. It's more higher and more accurate, better than the previous displacement one. Okay, let's go to the next technology, vibration sensor. It is an alternate method of measuring the density of any fluid. The fluid will pass through a tube which has a flexible mount so that it can vibrate when driven through outside the source. The amplitude of vibration decreases as the specific weight or the density of fluid increases. It's opposite relations. So that by measuring the vibration amplitude, the specific weight density can be calculated. It is built on idea of harmonic motion of the spring. What's the harmonic motion of the spring? This is the macro motion device which measure the density. The fluid will go through this tube and the tube start vibrating as you see in here يا شباب. See the sensor, how can they act with the vibration of this tube? U-tube, we call it U-tube, U shape, in the U shape. Now it's filled by the material and it will vibrate. Inlet back off and outlet back off. The inlet when mean لحظة دخول المادة جوة الأنابيب. outlet لحظة خروج المادة من الأنابيب. طيب in phase, that's mean at the same angle. But if there is a material start in there and the density change, see the vibration, how can it affect on the sensor catching frequency. And you will see there is a change in the phase. Shift, phase, shift, phase, shift. Now by finding this phase shift, I can find delta t. And I know that the acceleration is opposite, it's proportional to the delta t. So I can find there mass flow rate. Then frequency, I can catch the density by using the frequency. I know the delta t now. Just find the frequency by converting this delta t 1 over the time and give me the resonance frequency. Maybe you can see here the difference in the masses. Heavy mass, it has heavy frequency. Light mass, it has frequent or very fast frequency. So if the material is heavy, its frequency becomes heavier. If the material is very low, its frequency becomes upper. So this is the relation. This is the relation of its density is opposite relation to the square of the frequency. Another method for measuring the density, which is the differential propellers. It's based on the idea of changing the pressure. It is the idea of changing the pressure over the difference in the height. If we fix the height and make it fixed, we can just measure the change in the pressure here, and based on that I can measure the density here. So as example, let's take this example. What is the density of a liquid in popular system? If a pressure of 500 Pascal and 2300 kilopascal are measured at the depth of 15 centimeter and 6.5 meter respectively. See here يا شباب. This one is example. There is here height and here the another height. In our example, it's saying that this one is 15 centimeter, while this one is 6.5 meters, and it gives me the difference between them and the pressure. See here, this is the high and this one the low and high. So in our example here, I can utilize the same formula. Density is equal to the differential pressure over the G over L, and we know that L, to find it, is 6.5 meter minus the 15 centimeter. Of course I divided by 100 in order to unify the units, so it gives me 6.35 meter. This is the height. Then substitute the height here for the L. it give me differential pressure which is 2003 or 23,000 minus 5 23 كيلو باسكال يا شباب 23 كيلو باسكال. It is kilo, that's why I put 3 zeros here, and 500 pascal here, which is the low density side. Just subtract both of them and divide them by the acceleration of gravity and the length that we already found it here. It gives me the result, which is 361.193 kg per meter cube. So this is the simplest method. It is simple method and it is helpful. Most of the time is used for the reservoirs and tanks, because here you just put a simple tube, not cost. So if you have some corrosive material or some harsh material, just put a tube on it. Even though if the tube is raided or it's exposed to the corrosion, you can change it simple and it's not that much cost, in order to save your devices or your sensors. Now other techniques also used for measuring the density, like radioactive sensor or vibration forks. This is the density meter using the nuclear atoms or nuclear material. Here is the emitter that emits the radiation, and here are detectors that detects the radiation that went through the pipe, and here a display panel that show me the readings of these radiated waves. Now the material go through the pipes, the active substance will radiate and start reading. If the material increases in the density, see the waves will disappear through the material and will not reach in the detectors. So the amount of wave reached there, it becomes very low. That means more density. And this is the another method for measuring the density. It is the vibrated forks. Also the same principle like vibrating tube. See, if you have a mass, heavy mass, it has low frequency. Light mass, it has higher frequency because it's lighter, easier. So the density here is opposite relation to the frequency. The same principle, shabab, almost the same, vibrating, but instead of putting a tube, I just only put forks. And here is the piezoelectric crystals with the temperature sensor, in order to give you also the measurement of the density using the vibration forks. This is the device, and it gives you here some displacement. Is manufactured by one of the companies, Emerson, I think. It's called motion. See here, the material with the very heavy density, it will go through the forks. The forks start vibrating, and these vibrations will go through the sensors, as you see here, and this vibrating will be generated in order to give you the signal to the my transmitter, as seen in the picture here. If you take it out, maybe you notice their vibration will be affected a little bit more, not like previous. So there is some difference in the vibration here. Will change the frequency of the vibration, but of course still you are measuring the density. Maybe if we see here, this is depend on the real-time density measurement accuracy up to 1 kg per meter cube or up to 0.001 gram per centimeter cube. So this is the type of my fork measurement. Okay, shabab, by end of this video we already covered the subject of the density. We talk about the density in details, more details, and we take some formula and we solve some example for it. Don't forget, ya shabab, solve the question number 1 of the quiz number 1. and I will give you a location where you will submit this quiz. Thank you شباب for listening and waiting me for the third lecture. السلام عليكم.